So hopefully by now you're getting familiar with the three types of collisions. Sometimes objects collide and they stick together. We call that a perfectly inelastic collision. In a perfectly inelastic collision, momentum is conserved, and we can express it for a two-body collision with an equation that says the momentum of object number 1 combined with the momentum of object number 2 added together prior to the collision has to equal the final momentum of the two objects that are stuck together after the collision. So when we add the two masses together and multiply it by the final velocity, we calculate the overall final momentum. The second type of collision is one in which the objects do not stick together, but there is still some loss of mechanical energy. In that case, we say the collision is inelastic. And the equation says the momentum of object 1 added to the momentum of object number 2 before the collision has to equal the momentum of object number 1 after the collision. So here we use the symbol V instead of U, plus the momentum of object number 2 after the collision. Okay, a third type of collision is the elastic collision. In the elastic collision, just like the inelastic collision, the objects do not stick together. So we have the same equation, m1u1 plus m2 u2 equals m1 v1 plus m2 v2. Okay, but on top of not sticking together and having the objects remain separate, there's another defining feature of the elastic collision, and that is that there's no amount of kinetic energy that gets converted into thermal energy. So we can say that 1/2 m1 u1 squared, which would be the initial kinetic energy of object 1, added to the initial kinetic energy of object number 2, that has to equate to the final kinetic energy of the two objects after the collision. So 1/2 m1 v1 squared plus 1/2 m2 v2 squared. Okay? There's two equations that describe the elastic collision, and so I think what we should do is demonstrate numerically an example of two objects that collide in these three different ways.